two complex signals are going to add here. Complex means not in that way, so I'm going to give some different here. If you see, this graph is somewhat more complex than previous examples that we say. In that manner I have given this one. So please pause the video and try to answer it. So this is just the addition of two signals that we have clearly saw everything with the example also we have saw. So please pause the video and try to answer it, and then I will solve. Then you guys can cross check it whether your answer is correct or not. Okay, please pause the video and try to answer it. I hope you guys able to solve this answer. So let me track the signal first. So that is the first rule. So here if you see, if you track the signal here, so this will be, the slope will be equal to 0. So s is equal to 0. So here the net transition is 1. So here the slope is 1. So here the net transition is 1. Here the slope is minus 1. So this is also minus 1. Okay, then after that the signal is equal to 0. So here the net transition is minus 2. So here the slope which is equal to 2, because over the one interval it is changing to value. So this is minus 2. So here the net transition is positive 2. So here the transition is 2, positive slope 2. Okay, so here if you see, over the minus 2 to 1 there is no x2 signal. So this is x2 of t, this is x1 of t. Okay, so at the region of minus 2 to minus 1, so there is no x2 signal. So this we can directly add it. So let me do that one. So if we directly trace this one, so this will be 1 here and it will directly go here. Okay, so there is no change in that. After that, if you see, here there is minus 1, here there is minus 2. Means what will happen? The net transition need to come to minus 3. So here the value is 2. So here the value is 2. So here if you see, the previous position holded is 2. So this will be 1. So if we now we have to change this to minus 3 position, means this will be drifting to minus 1. So up to minus 1 it will be changed. So this value will go minus 1. So after minus 1, the slope is again minus 1 plus minus 2. So this is minus 2. So the slope will be minus 3. So then what will happen is that this will be dipping to downwards. Okay, so if we name the one, so this is minus 1, so this will be minus 4. So here the slope is equal to minus 3, here the netted transition is minus 3, so this will be 1 and this will be as it is 1. Okay, now the previous position is folded. So if you see, there is no transition, there is no, the x1 is completely 0. So now we have to trace the x2 as it is. So here it is minus 4, right? So the plus positive 2 quantity is going upward. So now what will happen? It will go upward by 2 quantity. So 2 means up to minus 2 it will go. So here it will be up to minus 2 it will come. After the minus 2, the slope is positive 2, right? So this will again go to 1. Okay, so this will resemble as it is. So this is how we have to draw the signal. So this is positive 2. So plus 2 will be traced. Here the slope is plus 2 as it is. Okay, so this value is 1. So this is a 2. So this is how the y of t which will be coming. So y of t is nothing but x1 of t plus x2 of t. I hope you guys are able to understand things, right? So everything is very easy. So just we have to trace it and just we have to add every values there. So with the help of my rules, you guys will be able to solve it easily, I think. So that's it, guys. So this will not be that much difficult. So addition of signal is not that difficult. This is a matter of mathematics only. So I hope you guys were able to do this. In gate examination, we directly, they won't ask the addition of signals, but in your college examinations, you guys can expect these questions. Where it will be help is that while solving the advanced things like in a Fourier transform, Fourier series, we use some shortcuts to find out the answers. On that time, it will be very much helpful, guys. So for that only, you guys have to learn this one carefully. Okay, so now we are going to the next topic, that is the most weighted thing, that is the standard signals. So here we will be discussing everything like Dirac Delta, unit step, ramp, impulse, everything we'll be discussing there. So let's start our next thing, that is the standard signals. So these all will come under classification of signals only. So what we have completed so far is that operations on dependent variable and independent variable. So we have completely completed that one completely. And then under the classification of signal, continuous time signal and discrete time signal, that we have done. So now before going to the next signals like odd even signal, some prerequisite is needed. So that thing I am going to take here today. So that thing is that some standard signals, every time I was stating that, right? So there is this is called as a unit step signal. So this is the unit step signal. So here x of t will also called as u of t. So I will going to explain what we mean by this unity, u of t, and then other signals like del of t, those things are there. I will explain everything in this class. So first signal that we are going to take is the unit impulse. Unit impulse. We know, right? Impulse is nothing but it will come only at a very small amount of time. That is, it will come and then go. It will vanish. So resembling the same, the unit step signal will be wrote like this: del of t over the time period t. Okay, this is how the notation we use for del of t. So the signal will be named as del of t. Okay, so that is what the Dirac delta. Sorry, this is impulse. So graph, how the graph will look like is that. So this is how the graph will look. So this is the time axis. How the impulse signal will resemble is that. So only at t is equal to 0, there will be a impulse. So that's it. So only this is what the entire graph is this. So every value other than the 0, the signal will be 0. So this signal is x of t. X of t is nothing but the impulse signal. Okay, so only at this value it will be 1. So the value of the impulse will be 1. Okay, so even at 0 minus and 0 plus, the value will be 0. Okay, so the del of t which will be equal to 0 when t which is not equal to 0. Okay, this is how the signal. So if we integrate the area of the impulse signal, minus infinity to infinity, del of t dt, this value of this graph will be 1, because the del of t, the constant before the del of t signal is 1. So that's why the area will be 1. So even if it is from 0 minus to 0 plus, del of t dt. Okay, so only at that point only the signal will be pointing. Rest all the point, the signal will be 0. So that is what the significance here. So I hope you guys able to understand this, right? So what will happen if we have some constant multiplied with that? So if we have the constant multiplied, now let me take the graph here. Here if 2 is multiplied there, if for an example, if this is x of t and this is the impulse, but this value is 2, then this signal will be called as 2 del of t. Based upon the constant multiplier, this value will change. Then what will be the integration value is the minus infinity to infinity del of t dt, which will be equal to 2. Okay, so this will be the area of the graph. Even 0 minus to 0 plus del of t dt, this value will be 2. Okay, so this is what the significance that we have to take into picture. I hope you guys able to get it right. So let's see some properties of this signal, impulse signal. So properties. So now the significant properties is that the del of t is the even signal. Even signal means the positive value, sorry, the time axis negative value and the positive value need to be same. But here if you see all the values is 0, expected 0. So this value will be considered as a even signal. Okay, so that is what the thing. So second property is the time shifted impulse. Shifted impulse. So if we do the shifting operation, how the impulse signal will be varying is the just a shifted simple impulse signal. So this is another one very important thing. So for an example, if we are multiplying, if we have to find out t minus 1, t is negative, right? So then what you have to do, we have to shift this value by plus 1. Forwardly we have to shift this value. So the signal graph will be as it is, just the value will be shifted to 1 degree apart from that. So this will be shifted like this. So that's it, everything will remain as it is. So this is 1, so this value will be 1, this is t. Okay, so this graph is the del of t minus 1. This will be just a time shifted version. Now this will be not even. So if we have shifted, this is non-even function. So only the non-shifted impulse function only even function. So this is very important, guys. So this will be. So here if you see, the graph will be from 1 minus to 1 plus del of t minus 1. So here dt. So this area will be only 0. Because at 0 the impulse is not there. So over this interval only the area will be 1. Okay. So this is one important property. So time shifted has some rules over it. So let's see the third property. So whenever we are doing scaling there, so del of at, so if you multiply with the del of at, then how this will be changing is that 1 divided by modulus of a del of t. So the value which how we are scaling, that will be changed like this way. So fourth property is that del of minus at, which will also be equal to 1 divided by minus at del of t. So both will be same, right? So that's it. So for an example, if del of 2t which is given there, how this graph will be changing is that, so this will come like this way. So this is as it is. Then the value which will be changing like 1 by 2 del of t. So the area will be get affecting. So this will become 1 by 2. So that is how the area will be getting changed. So everything will be 0. This will be 0, everything is as it is. So just this will be getting changed. I hope you guys are able to understand things, right? So that is how. Some other properties like shifting, scaling, how the affecting is that. Fifth one. So if del of minus bt plus c. So if that is happening, then how the signal will be there is that. So if we take b common, so what will happen? Del of minus b t minus c by b. Okay, so this is how. So this will be even changed as minus 1 by b modulus del of t minus c by b. So this is how it will be changed. So that's the time shifted version and then divided by b. So this is how. So sixth one is there. Let me write another one. That is if positive bt plus c, then how this will be changing? 1 divided by modulus of b del of t plus c divided by b. Okay, this is how it will be changing. So these are all some normal conversion only. So another one important property is the sampling of thing. So ninth one, or ninth one not, two thing I skipped it. So seventh one, multiplication of impulse, multiplication or sampling. Okay, so if there is a two thing, so we have already seen in the conversion from continuous signal to discrete signal, right? So we will be multiplying with the impulse train. So that is done this with this impulse train only, guys. So for an example, if we have the signal like this, so let me have the random signal. So if we have signal like this, so if we are multiplying this with the impulse, so here the impulse signal is like this way. So if we are multiplying this impulse, so this is x of t, sorry, the red color is del of t, so red color is del of t, and the normal thing is x of t, white color is x of t over the time period t. So if you do this one, then the output will come, right? This will be the multiplied version of x of t under the del of t, sorry, impulse t. So this will come like this way. So this point will be x of t dot del of t, the sampled version. It will come like as it is. So that is how. So if you see how this can be found out is that here the value of x of 0 will come here. So this value will be same, x of 0. So how the thing will be there is that when we multiply the impulse train with the normal signal, here if you see the t value is equal to 0. So this value will apply here. So this value will come as x of 0. So the output will come as it is. So this is how the rule that we will be following here. So the next rule, next is that breakout argument like this way only. So let me write few more things. So with extending to this one. So first thing is that when x of t, which is multiplied with the normal del of t, then value will come as x of 0. That now only we have saw. So because now here the t is equal to 0, that will be get applied here. If you take any other example like x of t with the shifted time impulse t minus t naught, then here the t naught, t is equal to t naught. So that will be get applied here. Then the resultant value will be x of t naught. Okay. I hope you guys getting my point, right? So if x of t is multiplied with del of minus bt plus c. So here what will be the timestamp value? The timestamp value will be c by b. So that will be get multiplied here. So if you see how this will be changing is that x of t 1 divided by minus b modulus, then that will be changed to x of del of t minus c by b. So this value will be, I need to apply it here. So then this will be changing to x of c by b 1 divided by modulus of b into del of t minus c by b. So this value will come like this way only. So this is how we have to find out the value. So this is very important, guys. Please make a note of it, how this is changing like this. First we have to find out the breakout point, and that we need to substitute in the x of t, and then this one also we need to, the area of this one also will be changing. Okay, so these are very important discussion. So I hope you guys getting my point. So in next class we will be seeing some more integrational property over there, so that I will be discussing in from next class. So stay tuned, guys. So please like, share and subscribe the channel, so that you guys will be motivated more to learn like this. So motivate me also to post more videos like this. So if you guys have any doubt, please post in the comment section. I will be there to solve this. Like, share and subscribe the channel, guys. Thank you.